Hello everyone, I'm Varun. So in today's session, we will focus on how files actually works. Basically, the part where we will focus is how file formatting works. Okay, file formatting basically means if there is a file, there are different types of file: text file, MP3 files, video files. So each one has their own different type of formatting through which we stored in the hard disk. Okay, because recognizing a text file is very different from recognizing an MP3 file, an MP4 file, and a picture file. Okay, so in the first part of this session, we will understand how file formatting works. Okay, in the second part two, we will see how actually files stored in the hard disk. Okay. So now let's continue with the lecture. So basically the topics which we are going to cover today is what is file format, how file format works. Okay. And we will see in depth of how file formatting works for text file, audio file, and picture file. So what is a file? Basically, a computer file is a computer resource for recording data in a storage device. Okay, it's just a medium through which we record our data. And the recording of data, it could be a text data, it could be MP3 data, it could be MP4 data, it could be anything. Okay, and basically a file is stored in a computer storage device. So what are the types of files? So the first type is text file, music file, picture file, video file. Okay, there are many more actually, the programming files. So executable files. So basically right now we are just seeing the basic ones: the text file, music file, picture file, and video file. Now, what is file format? Okay, if the data inside the file is organized in some manner, this is called file format. Okay, so basically a file format is a standard way in which information is encoded for storage. Since you know that a file, as I told you, there are different types of file: text, music. So encoding will be different for text, encoding will be different for music. Encoding basically means how we are actually recognizing the file. Recognizing a text file is very different from recognizing a music file, because the music will contain the data like which we hear from the speaker. Picture is actually the digital, you can say, picture, it is in the picture format. Okay, so since four these four files are very different from each other, so that their encoding method will be different. So that's what file format is. Okay, so a file format says that is a standard way that information is encoded for storage in a computer file. For example, JPG, PNG. Encoding JPG is very different from PNG. If you try to open a JPG file using PNG software, then it will not open. Okay, so now the best thing about file format is like you can create your own file format, but the standard one is text, MP3, JPG, okay, WAV. So these all are the standard file format. Now let's move to the first part, like what is a text file? So a text file basically which contains the data in a structured way as a sequence of a line in electronic text. Basically, you will see the characters in the text file. So, and text file we actually stored as data in our computer file system. Okay, so how formatting actually done? So first, the data in which it is present in the hard disk, it is in the binary format. After we convert the binary format into decimal, and then we finally come to ASCII. ASCII basically in the word format, like in the like readable text. So let's see how data is stored in the hard disk. So when I'm talking about a file, so of basic text file, data is actually stored in this format. This is binary format. So every data is actually stored in the binary format in the hard disk, because in the hard disk it can only recognize the data in this digital format 0100. Then this is binary ones. Okay. So 0 basically means off, 1 is on. So basically this is the sequence through which the data is actually stored in the hard disk. Now, but the basic point is, suppose this data is saying, hi, I am Varun. Okay, and this is the binary format of that data. So the question is how we encode this data so that I can get the text from it. Okay, so this is a conversion. So you can see that this is a binary number 1010. So I'm converting this binary into decimal. Okay, so for first, what we'll do, we will convert this binary into decimal. As I told you here, first we convert this binary into decimal, and then we'll convert into a text. We cannot directly convert binary into text. We should go to the decimal format first. So how to convert this into decimal? So to convert into decimal, suppose we have a binary number 1010. Okay, now try to move from right to left. Try to move from right to left. So in the binary encoding system, what you will do, this is the value 0, 1, 0, 1. And this is the position 0. This is the position 1. This is the position 2. This is the position 3. Okay, so go from right to left. First, take this value 0. Okay, multiply it with 2 to the power the position of that number. So position is actually 0. Now take this another number, that is 1, into 2 and that position of that 1 when I'm taking the position from the right to left. So 2 to the power 1. Now take the third number, 0 into 2 to the power the position of that number, that is 2. And the third one, this is 1 into 2 to the power position of that number, that is 3. When I sum up this number now, okay, you have to use this 2 because it is in the binary system we use basically 2. Okay, when we are using some decimal system, we will use 10. So right now just focus on the binary decimal. So in binary decimal, we will multiply with 2 to the power. Okay, so after this, when we add this, we will get 10. So this is our result. Basically, we convert this binary to decimal system. Decimal basically means like this 10, 11, 12, 13, 14, 15. So now we have converted. So this data is actually converted into decimal. So right now we got this. Okay. Now our task is to convert this binary decimal into ASCII. After converting ASCII, we will get our text. So how will, so there is an ASCII standard, ASCII character encoding standard. Okay. This is a predefined standard which is already there. Okay. In which they have defined that which number is corresponding to which character. Suppose 65 is corresponding to A, 66 is corresponding to B. Similarly, we will do all this thing. So right now what we'll do, one second. Now here you can see that we have 72. Now we will convert this 72. 72 is corresponding to H. Okay, and 105 is corresponding to I. HI, basically high. It is becoming high. Now after when I convert this, one second. So when we convert this, so first 72 becomes H. After this, it completely becomes high am carry any. So basically it is the representation. This binary is the representation of high am carry any. So this is how actually our binary data actually stored, or actually formatting, how formatting actually works. How we take out the data from the hard disk, okay, and how we format the data in the text format. So these all things are actually done by our text software, which is doing all these formatting. Now the second type of thing is WAV file, that is audio file. How now we will see how the formatting done for audio file. So WAV file is actually the audio files. Okay. Now before like you have to understand this one thing more. Okay. So when we are reading the data now, suppose we have our data is actually stored in the basically in the hard disk. Okay. So in the hard disk, the data is actually in the binary form. When we take out the data, so there is a specialty with the audio data that each audio data is actually containing some extra information. So that data is actually known as metadata. Just read this statement. Before we can correctly read the data, we need to know some information like the bit rate, whether it is a single track or stereo data. About data is called metadata. So it is saying something about data. Okay, suppose you enrolled in a college. Okay, and college gave you an ID, an ID card, which contains your information like your roll number and all those things. So that is actually, you are the main part of the college. Okay, so you are the main entity and you are containing something which is talking about yourself. Okay, so data about data is metadata. So when we have the audio data, so we also have the metadata. Metadata will say about that data key when that data came into us. Okay, so at what rate, what is the bit rate, like through which this data came, and what type of data. Is it a single track data or stereo data? So that data is actually known as metadata. So we will get the metadata for each audio file, okay, which will tell us about that data. So before we read the data, we need to know some information like bit rate. This metadata is stored at the front of actual data. So where our actual data is present, it is present just before that. okay, and it is present at the position known as header. So header is of 44 byte. So you can say that metadata is 44 byte. So now this is our metadata. In the initial, it is storing some specific, like some predefined words. After that, it is like it has stored the total file size of that data. After this, it has stored the word WAVE, which is saying this data is actually this file is actually related to wave format. This is how the audio player defined their data. This is how audio player are actually, from the metadata, they will identify that, okay, this file is a WAV file, this file is an MP3 file, like which audio file is this? After that, you can see that a header size, audio format, like there are many things are stored here, byte rate, sample rate, this some technical information. After that, it will store the data size. Okay, suppose you have a movie file of 700 MB. So it will contain the data size of 700 MB. Okay, the data which is going to come, it is of 700 MB. So by metadata, you will get the information about the data. Okay, what is the data size? What kind of file is it? It is a wave. It is a MP3 or like what it, and sampling rate, audio format, and all these things. After this data, our actual data actually present after this. So you can see that previously there was no extra data here. After that, now you can see that this is our ordinal data attached to this one. Now, let's look at the waveform hello. Suppose we are considering a message signal. So this is a signal for hello. We have recorded this data using our microphone and we got this data. Now, after this, we will zoom this data. We will zoom this data. Okay, so after zooming this data, you can see this. Okay, now we will do the sampling of it. Okay, we will do the sampling of it. Sampling basically means a digital micro, basically your digital microphone samples the sound pressure thousands of times. Each sample is represented as a number. Large number means high sound pressure called amplitude. So basically this is the amplitude. The distance from the wave to bottom is the amplitude. Okay, and what we'll do, this is our wave. This is our wave. Okay, and we have drawn the line from this one in this way. Sampling the data basically means like drawing the lines from like at each place. Okay, at each place we have drawn the lines. Now after drawing the lines, what we'll do, we will write the values of it. So you know that from this position to down this position, the distance is actually -3, because it is the bottom minus minus y coordinate. Okay, this is bottom minus the y coordinate. So the distance is actually -8. Similarly, we'll do this for each one of this data. Okay, and after that we will okay, and these numbers now stored in the wave file. Thousand of amplitude for every single second, every single second of audio. So there will be 1,000 of amplitudes. This is one amplitude. This is second amplitude, the third amplitude, fourth amplitude. So every amplitude now we are going to store in the file. Okay, these are our amplitude and these are our sample. This is first sample, second, third, fourth. Okay, likewise we put the sample like each of the wave at every place, at each position. Okay, and now after this we will put this data in a array. Now you can see that -3 will store here, -8 will store here, and we will attach this data after this. Here you can see that here is our actual data. So that data is actually will be present here. This is how our data is stored in the hard disk. Okay, because we cannot directly store the waveform. So what we have done, basically we have taken the audio file, we have sampled it, and we have given this amplitude number. After giving the amplitude number, we have stored this data into our hard disk. Okay, now when we play this file, suppose this data file is actually, this data is now contained in the basically in our hard disk. So what we'll do, the audio program, whatever audio program you're using, suppose the MP3 player or that WAV file player, it will actuate the computer speaker. Basically, it will transform this numbers to the wave, to that amplitude. It knows that -3, -8, like move to this amplitude and play the file using this amplitude. Now, using this amplitude, it will try to generate the original wave. Okay, now it know that I have to generate the wave of -3, the -8, -11. I have to generate all these amplitude, and after that, basically audio file is generated. So this is how actually our audio file is stored in the hard disk, in what format. This is the way how formatting is done. Okay, now let's move to the third type of file, that is bitmap file. It is used to store the pictures. Okay, pictures are made up of tiny little square elements. That square elements are actually called pixels. It also has a metadata. So basically pictures are made up of tiny little square elements. So that square elements are actually called pixels. Since you can see that here, there's a dinosaur, but this dinosaur is actually created from small boxes. So these small boxes actually a pixel. You can say this is a pixel. Okay, and this pixel has three values. It is made up of three values, that is RGB. Okay, R, G, red, green, and blue. And by combination of these RGB, we will create all the colors. So it also has a metadata. Since likewise in the audio file, you have seen that with the data we have a metadata. Similarly, in this video file also we have a metadata which will contain the image width, height, color, and depth. Okay, let's see this. Here you can say this is the metadata for the file. BM is actually bitmap. This is the total file size, reserved. Okay, header size, and this is the image width and the image height. This is the image width, image height. Suppose your image is of size 720 into 1024. Then your width is 720 and height is 1024. Okay, suppose your image is of 4 by 4. Then image width is 4 and image height is 444. So that image will be 4 by 4. And it will say number of image planes, and it is a color depth. So color depth is basically, it is of 24. So right now we are considering a data where our metadata is actually saying the image file which is going to be come after this. Okay, like this metadata is actually representing some actual data, and it is saying the data which I am representing is of size 4 by 4, and it has a color depth of 24. Why 24? So basically 24 is made up of three 8-bit using three 8-bit colors. So first 8-bit is red, second 8-bit is green, and third 8-bit is blue. So RGB. So that's why this color depth is 24. 8-bit for red, 8-bit for green, 8-bit for blue. Now let's read this. Each pixel is a combination of three colors: red, green, and blue. These are called additive primary colors, and they can be mixed together to create any other color on our electronic displays. Okay, so basically a pixel is a combination of three colors, RGB, and using those combination of these colors, we can create the another one. That we can create any colors. So this is this, like this 24 is actually because of 8-bit of red, 8-bit of green, 8-bit of blue. Now, after that, our data come. After this, similarly, like for the audio file, you have seen that after metadata, our actual data came. Similarly, here also our video data will come. Okay, so the data will contain the values of pixel. So this is our data. After this, what we'll do, we will take 3 pixel at a time. First, we have taken the first pixel, then we'll take the second pixel, and then we will take the third pixel value. It is not a pixel value, it is just an integer values. Okay, don't consider use. By combining 3 integer values, we will generate a 1 pixel. By combining 3 pixel, we will by combining 3 integer values, we will generate a pixel. Okay, so basically 2555 is representing red, second one is representing green, third one is actually blue. When we will combine this, it will make white. Okay, and we will put this white in 4 by 4 matrix. Why this matrix is 4 by 4? Because in the metadata is already written that image width is 4, image height is 4. So after that, after combining this, we will create a matrix of 4 by 4, and we will put our image white here. Now, after done with the first 3 colors, we will do with another 3. Like this one is red, second one is green, and third one is 0. It is nothing. So when we will mix this color, okay, so we will get yellow. After combining this, we will get yellow, and we will put that color in. Now, after that, we will again consider the next 3 values. So next 3 values is actually 0, 0, 0. And after combining these values, we will get black. So we will place the black here. Again, we will move ahead. We have taken the first color red, second green, and third one is 0. That is again yellow. Okay. So it will again yellow and it will go here. Similarly, we will do this for like all the values, okay, till the end, and we will generate a picture here. So this is the picture. This is the picture. You can see that picture. It's something like Pac-Man. Okay, so this is how actually our picture is actually generated. So you can do this same thing which you have done for this 4x4 image. You can do this same for this big picture. Okay, and for the picture you can generate a basically you have some that pixel values like 0 to 55. All these values will be stored in the hard disk. So this is the thing actually, how the data is actually stored in the hard disk, like for file formatting. So this is the metadata for the video file, and this is the actual data. This 0 to 255 is the color range. Okay, so this is for the first. This is representing R, this is representing G, and this is representing blue. So right now that this red is 255. This is very dark. Okay, you can put this value 255 to 200 also, but in that case this red value, this red color will become little bit dim. Here in this case also, for green also, and for this blue also. So by combining three values at a time, three integer values at a time, we will get one value that will be the final one, which is our pixel value, and we will keep on putting those values in our matrix, and finally we will end up with some picture. So this is how our images file are actually stored in the hard disk. Okay, and when we take out those files, so how the file is actually generated from those values in our screen, it is like in this way. These calculations are like actually happen on that data. So basically for every for every other thing also, like we have talked about text file, audio file, picture. Similarly for video file and other formats, the picture, the main picture is actually the same. So final point I want to say, under the hood, they are all same. Okay, long list of numbers stored as a binary in a storage device. First, there will be a metadata if required, and after that, there will be a sequence of data, the actual data you will see. And file format are the key to reading and understanding the data inside. So that is the beauty of file format. File format helps you to store the data, okay, and basically reading the data. Reading that, basically it is not help in storing the data, it is basically help you in reading and understanding the data inside. Thank you.